Who discovered black holes? And what is the theory behind this? In 1916, Albert Einstein predicted the existence of objects with gravity so strong that light cannot escape as part of his general theory of relativity. However, the term black hole was not used at this time. In the 1930s, Indian physicist Subramanian Chandrasekhar calculated that a star more than about 1.4 times the mass of the Sun would not be able to support itself against its own gravity after exhausting its nuclear fuel. This helps explain how black holes form. In the late 1930s, American physicist Robert Oppenheimer was the first to use the term black hole to describe these ultra-dense, gravitationally collapsed objects predicted by Einstein's equations. In the 1960s, theoretical work by physicists like John Wheeler, Roger Penrose and others helped further develop theories around spacetime singularities and the no-hair theorem for black holes. This contributed to our modern understanding. In the 1970s, work by Stephen Hawking and others theorized that black holes emit radiation, now known as Hawking radiation, and eventually evaporate over extremely long timescales. This showed black holes are not entirely black. Albert Einstein originally predicted the existence of black holes in 1916 as part of his general theory of relativity. However, he didn't call them black holes. The equations showed that sufficiently compact mass can deform spacetime to form a black hole. In the 1930s, Subramanian Chandrasekhar calculated the maximum mass a white dwarf star could have before collapsing into a black hole, now known as the Chandrasekhar limit. This helped explain how the most massive stars can collapse into black holes after supernova explosions. In 1939, Robert Oppenheimer was the first to use the term black hole in reference to gravitational collapse during lectures at Caltech. He described them as extremely massive stars that have collapsed entirely inward due to gravity. In the 1960s, John Wheeler theorized about the existence of spacetime singularities within black holes. Roger Penrose proved that black holes will always contain singularities. This helped establish theoretical properties of black holes. Stephen Hawking and others in the 1970s showed that quantum effects cause black holes to emit radiation known as Hawking radiation. This causes them to lose mass and evaporate over extremely long time periods. In the 1990s and 2000s, physicists developed a holographic principle which relates properties inside the black hole event horizon to information encoded on the 2D surface boundary. This has illuminated quantum properties of black holes. Starting in the 1970s, astronomical observations have gradually established the existence of black holes through measurements of intense gravitational effects and accretion disks around them. So, our modern view of black holes has developed over many decades as a result of both theoretical predictions and more recent astronomical observations. The foundational ideas came from Einstein, Chandrasekhar, Oppenheimer and others in the early 20th century. What was the role of Albert Einstein in the black hole? Albert Einstein made crucial contributions to the theoretical understanding of black holes. In 1915, Einstein published his general theory of relativity, which described gravity as the warping of spacetime by mass and energy. In 1916, Einstein predicted the existence of objects with gravity so strong that even light cannot escape. This was based on his equations showing that sufficiently compact mass can deform spacetime enough to prevent light from escaping. Einstein did not actually use the term black hole. But his concept of an object with an escape velocity greater than the speed of light was the foundation for the later conception of black holes. In the 1930s and 1940s, physicists like Oppenheimer, Fritz Zwicky, and others built on Einstein's foundations to theorize about frozen stars and gravitational collapse to infinite density, foreshadowing our modern conception of black holes. Einstein at first dismissed the idea of inescapable gravitational collapse as physically unrealistic. But by the late 1930s, he accepted the concept as a consequence of his equations. Einstein's theory of general relativity provided the crucial theoretical framework for describing extremely warped spacetime and super-strong gravity that prevents even light from escaping. This enabled decades of subsequent theoretical work on black holes. Einstein's insights on gravitational lensing also contributed to understanding how black holes can distort and bend light from nearby stars and matter. This helped drive predictions about observational signatures. So while Einstein was not the first to use the specific term, black hole, his general relativity theory provided the vital building blocks for establishing the theoretical basis and predictions surrounding black holes as we understand them today. The concept arose directly from his revolutionary descriptions of gravitation and space-time.